other node that I'm going to use is the pop sprite node, just to try to quickly visualize how big those grains are and everything to the solver. It comes in by default with that smoke puff. So I think the easiest way for me to fix that is just to go in. There's a sphere.
Sphere match.
Yeah, it's famous.
Yeah.
It's not that pretty to look at, but this is the one that they use for grains and for flip and stuff like that. They will color it kind of like a cent or something like that at some point, but just for visualizing the scale of everything, it's okay for what I want to do right here. So the next thing I'm going to do is try to get a little bit more grains inside of him. Everything's solving kind of in real time or whatever, so I'm not too worried about having too much detail and slowing everything down. And then the one thing that I'm kind of concerned about is just like his arms are like, I want some volume in them. I don't just want like a single strand of particles to represent his arms. So if I go out of the DOP network, I can cut that value in half. And I can see now that it's behaving more like I would expect. The next thing that I'm going to try to do to get like more of a granular solid behavior is have it make these explicit constraints. Because I never want everything to really fall apart completely. I just want it to kind of stay stuck together. And then there's a problem where everything here just keeps expanding forever. There's a few things. The first problem that I see is that these explicit constraints have a weight of 0. So I think that's just causing this grain to ignore the constraints and just not really apply any forces or anything to maintain them. I could see now that he's falling like into a little puddle or something like the guy in Terminator. He's getting a little bit flat. I'm not too concerned with that problem. The one thing that I'm going to try to do is just introduce some more stiffness to try to get those constraints kind of holding it together a little bit more. And I can see that's kind of working like I want it to. The other thing that I'm going to do is turn on that OpenCL parameter that I was talking about last class. That will just kind of speed some things up. Then I'm going to increase the constraint iterations, and you can see now it's kind of doing a better job preserving his volume. Basically, with that motion of him falling so quickly, if the solver doesn't have enough iterations to kind of maintain the length of the constraints and enforce the distance that they should be apart from each other, it won't look realistic, and it will start to kind of lose volume and feel a problem like that. So the more iterations that the solver has to figure out how far apart those will be, the more kind of stable, or the more your guy will maintain volume. If you're throwing like a thing of Jello at the wall, you would have like a similar problem where it's hitting the wall super fast and like squishing to no volume. So you might need to do constraint iterations in another situation like that. The next thing that I want to happen is like I don't want him to just be falling like in a puddle like that. I want some parts of him to be like doing what my source animation is doing, and then I just want certain parts of him to be like flopping around a little bit. So I'm going to use this rest frame right here. I'm going to use this paint node. This is kind of a useful utility in Houdini for just selecting different parts of a mesh. It's nice because it gives you like very art directable control. You don't have to use the like box picker or lasso or whatever. You know that like if you click, it will just be on that surface. It's like kind of like having a spray paint can, or similar to some sculpting applications and stuff like that. But I'm going to just start painting here. I'm going to try to get his arm to be a little bit red, and then I want to use that color to control which part of him inherits motion and which part of him is allowed to just freely get moved around by the solver. The easiest way to get that color from his surface mesh to the particles is just with this attribute transfer. So if you look just with wiring it up there, where you have the geometry to transfer to, and then the geometry that you're getting stuff from, it's basically copying that color value over just by proximity and how close it is, what's the closest point that it finds, and then what is the color value at that point, and then it will just copy that over. So now I'm going to use this attribute create node, and I can use that node and set a group. And I can look at that CD, which is like the attribute that stands for color diffuse, or basically the point color. And then .x is the first component of that, or it's kind of, for a position, it's XYZ, for a color, it's RGB. But Houdini is like super technical, so they just use that one notation. But if you just know that that's the first component of a vector, you'll know that that's getting the red color. So I'm going to use this to set the mass of my particles. Because I have the group, I just want this default value to set to 1. So basically anything that's not in this group will be set to 1. That's basically what this variable or attribute is being initialized to. But then this value, or anything that is in this group or falls under this condition, will be set to an explicit value of 0. Then I also just need a statement here to kind of compare. So I'm going to set that to greater than symbol. Then I'm going to switch that to points. And then I'm just going to use this spreadsheet quickly. It looks like none of them got any mass. I think the problem is that if stuff is red or white, the R value is always going to be 1. So if I use a different component like Y or the green component, that will actually change. I was just doing something wrong with my color map. So if I look now, I have some that are 1, and those you can see have a green or Y value of 0, and then when it gets to 1, the mass is being set to 0. So I'm going to kind of play this simulation and just see how that mass is affecting things. His arm is kind of dangling. I think with his foot, it's starting where it's already like penetrating the ground a little bit, and the way that the solver is trying to handle collisions is kind of giving it that weird result. So I'm just gonna put this down like a little bit so that it's not trying to push his foot like outside of the ground right away. So if I try that again, now I can see that his arm is kind of dangling around. But the problem is that nothing else is moving. He's just like a statue with made out of like marble, but then someone's melting his arm or something like that. So the next node that I'm going to use is I'm going to use one of these BOP nodes. That lets me use the this kind of node interface to manipulate the particles. And then there's this input tab. Basically, input 1, 2, 3, 4 show in the bottom of this tab. And these are drop downs where you can choose different any type of SOP that you want. Any type of DOP data itself, basically any other geometry you can reference using that kind of handle. But I'm going to set this one back to none, and then the second input I'm going to have be this first context geometry, which is the stuff coming into the first input of the DOP network. So this op input number 2 is a kind of handle that I can use to get stuff from that geometry. I can use this get attribute just to kind of check what's going on and make sure that stuff is being set up properly. I want to get the position attribute, or the P, which is like the point position, and then this I1 is the point or primitive number. It's kind of like the index that it's looking for. Because I know that this point count isn't changing, I can just use the point number of my current geometry that it's processing, and then I can just try to override the position. And now it's kind of doing something. It's not exactly what I want, because I don't really want it to be changing his arm. I just want it to be affecting like the white points. And I can use this bind node, which basically is a reference to another attribute on the geometry. And then I can use this mass attribute as basically a weight or a bias that I can mix between the point position that it currently has from the simulation or the solve, the point position that's this first input geometry, and then the bias will be that mass. And I know that it goes between 0 or 1. If it didn't, I might have to do some more things to ensure that I'm not getting unexpected results out of that.
Can you explain the bind on the
The bind is how you refer to an attribute from the geometry. Basically, you have these globals, or anything, whatever you want to call them, like the point number, that are all default, but there's no variable here that's built in for